All right, so this video is a reminder of some integration tips as well as adding on some more. So I'm going to start with something we call U substitution, and I don't really remember if we dug much into this, but we definitely used this topic before, but I'm going to officially call it U substitution as well. So say we're going to integrate something like this, and you can see that the derivative of the inside function is represented on the outside. The derivative of negative 3x cubed is negative 9x squared. So when you see that, you can say, oh, I'll just ignore that and focus on this part to integrate. That's what we did before. But now I'm going to give it a little more of a formal definition, and that's U substitution. The way that works is, okay, we're going to let all of this part right here equal U. Negative 3x cubed plus 1. Therefore, du equals negative 9x squared dx. Okay, well, now we just make substitutions based on what we wrote here. Negative 9x squared dx is all the same as du. So I can just write du right there. I just subs out that and that, because all of that is equal to du. Okay, now all of this stuff is equal to u, negative 3x cubed plus 1. So this just becomes u to the third. Well, we can integrate that easily. That's 1/4 u to the fourth plus c. And that's our answer, except now we need to, whatever u is, we need to put that back in there. So my answer to the integral is 1/4 negative 3x cubed plus 1 to the fourth plus c. And that's it. So that's u substitution. We've kind of done that, but here's a nice formal way of saying it. So now we're going to apply that to a slightly different problem here. Let's see. It's integral of negative 2x to the fourth minus 4 to the fourth times negative 32x cubed. So naturally, we want to see the derivative of the inside and the outside somewhere. Well, let's see. What is the derivative of the inside? It would be negative 8x cubed. That doesn't match this. So the question is, how could I make negative 32 look like negative 8? Well, if I multiplied it by, move the dx over here. If I multiplied it by what, I guess I need it to be a fourth of that, right? So negative 32 times a fourth, or also called divided by 4, would get me 8x cubed. So we can make that swap as long as I do something very important. And that is that if I'm going to multiply by a fourth in here, I need to multiply by 4 on the outside of the integral. Because what you're doing is saying, well, 4 times a fourth, that's 1. That doesn't change the value of anything. But when I write it like this, though, I can now see the derivative of that inside function right here. And again, we could use, go away. And you could use u substitution again. Say, okay, well, so now I got 4 integral. All this stuff is going to be u, so u equals negative 2x to the fourth minus 4. Du equals negative 8x cubed dx. So all that crap right there, that's du. And all this stuff is u to the fourth. Cool, let's just go ahead and integrate now. So the answer is 4 times 1/5 u to the fifth. And that's it. Oh, plus c. Okay, so let's go ahead and put my u back in there now. That's this right here. So this becomes 4. I guess I can do 4 times a fifth. That's 4/5. 4/5 times negative 2x to the fourth minus 4 to the fifth plus c. And that's it. So we're going to be using this trick a lot. Whenever you have something that's, you need to change it so that you have that integral on the inside and the outside, you got to put those constants in there. All right, so let's do one here. Why don't you try this? Cosine of x squared 6x dx. Okay, let's see. The derivative of the inside here would be 2x. So I would love to see a 2x, but I don't. Well, how can I make 6 become a 2? Well, I multiply by a third. But means I need a 3 out here. So now, let's go and use the substitution again. That worked out well. Can I click on that? Okay. So let's see. I'm going to let, that means I'm doing the integral of cosine of u. Ooh, that's not good, u. So u equals, I'm saying that, and so far, u has just been the inside function. In this case, x squared. X squared. So du equals 2x dx. So after I made this 1/3 thing, 1/3 times 6, that is just 2. So now I can see there that I do have 2x dx. That's my du. Du. All right, so let's do this integral. What's the antiderivative of cosine? It's just sine. You still got that 3 out here. So sine of u plus c. Make your u substitution back in there. So the answer is 3 sine of x squared plus c. And we can always check our answers easily again here. This derivative would be 3 times cosine of x squared times 2x, which is 6x cosine of x squared, which is what we started the problem with. So I can check my answers easily like that. We'll do one more here. So let's see, here's the problem going to be x divided by x squared plus 1 dx. You could, if you wanted, if it makes you feel better, could have written it like this: x squared plus 1 to the negative 1. Maybe that'll help, because then you can kind of see, oh, there's that inside function thing again. So I want to see a 2x on the outside. Well, so let's do that. Put a 1/2 out front, 2 on the inside. Okay. All right, so let's do this. I'm going to let u equal the inside function, x squared plus 1. So du equals 2x dx. Let's make some substitutions in here. 2x dx, that's same as du. Got a 1/2 out front. So I've got rid of those. And this is just u to the negative 1. Okay, so u to the negative 1. We haven't done this as much yet, so we're going to start practicing it now. That's the same as 1 over u. And the antiderivative of that is natural log of u. Okay, so whenever we see something like this, that's what's going to happen. 1 over u, and antiderivative is natural log of u. Oh, let's put our u back in there. Here's our u. So the answer is 1/2 natural log of x squared plus 1 plus c. I'm going to go ahead and check my answer here real quick. I like to do that. Derivative would be 1/2 times 1 over x squared plus 1 times 2x. That's the, remember, for derivative of natural log, you do 1 over whatever's in there times the derivative of this function. So those 2's cancel, and you just end up with x over x squared plus 1. And I think that's where we started, right here. Yep, so good. Check that answer there.